This is the latest version of SynthMaker, version 0.1 build 43. There are some new components for creating user interfaces, and I'm going to show how to create a chorus effect, which will be based on a Reaktor schematic or diagram. So I'll start with opening SynthMaker, creating a new document, and I like to start with the synth from the modules and plug it to MIDI input and audio out, just to make sure everything is working. Yeah, all good. So now we go inside the synth, and here I'm going to create a module with a user interface, which will be a chorus module. So I'll delete the sine wave because it will be better to use like a different kind of wave, like a square wave, and I'll use this table OS. The table OS is like the sine wave except a phase, and it generates a wave. It needs number of harmonics to avoid the aliasing, so we need to convert our frequency to the number of harmonics. It also needs a table. At the moment when you created it, it doesn't have a table. Maybe in the future it will start with a default table, but for now you need to set the table, and there's a component called wave selector that allows you to select between these waves, and when you select, the table comes out, so you need to connect it to set the table OS. I'm going to select square. So now when we play, we now have a square wave. We can also do scope wave to look at our wave, and coming out from there, and we need the gate going to it. Okay, so that's our square wave. We could choose something else like a sawtooth, but let's stay with square. Okay, so after our table OS and envelope, I'm going to create a new module that will place there. Now for creating modules with user interface, we need a view component, because it will show here in the front panel, it will show our custom user interface. And so to go inside this view, we click on that triangle, and now this is the schematic inside that view. The user interface is built from this yellow connector, and this one at the moment is not being used. It will be for modifiers like border, corner radius, padding, etc. This all follows the way SwiftUI works, so you can use the documentation that Apple provides for SwiftUI, and it should make sense here. In our view, we need this kind of connector. This is like a compiled code connector. We need to go in, and then we need to somehow come out there, and the way we do that is with an input, which is here, and an output. Output is there. So once we do this here, we'll have our connectors. Now when we play we don't hear anything because inside, when we go inside, these two are not connected to each other. So if we go now like this, we should hear. So inside here is where we will build our chorus. Now one thing that's quite useful is to have these transmitter components which transmit the gate throughout the schematic, and there's another one that transmits pitch, which I don't think we actually need, so I'll just do the gate. And in the future this might be transparent, so that when you don't have a gate TX it will still work, and all the gate RX components would just connect straight to the gate by default. So here we can now use our gate RX for actually I think in this case we don't need it, but normally you might need it to trigger ADSRs, etc. Okay, so now I'm going to look at the Reaktor thing. So there's like a triangle wave there that has like a frequency and an amplitude. So I'll start with that. There's a recent component which is these naive square and naive triangles. These are not anti-aliased, so they have aliasing at higher frequencies, but because we're going to work with very low frequencies, it should be fine. And we need a phaser. Actually, maybe I'll explain about the phaser here, and I'll do a scope wave to show. So, and actually here for the scope I'll use the gate. So this scope needs the gate because it always shows the last note played, so it needs to know which one was the last one. The gate goes up when you press a note and down when you release. So our phaser needs a frequency, which we can specify with one of these compiled float components. I'm going to give it a frequency of, let's say, 100 Hertz. And now I'm going to plot. Actually, I'm going to make a higher frequency. So this is 1000 Hertz, and here you can see that's our phase. It goes from 0 to 1. That 1 is wrong. It's a bug with the scope, but the wave should be fine. So it goes 0 to 1, 0 to 1 at whatever frequency we're playing. So this 0 to 1, it's like an angle, but instead of going to 0 to pi, it goes from 0 to 1. So that's what this triangle accepts. And then the triangle will produce a triangle wave with, this is called a naive triangle wave, because it doesn't take care of any aliasing. It's just plain going up and down and up and down. And there's the same for a naive, sorry, not triangle, naive square, which it's a similar thing, but for a square wave. So up and down, like when we looked up here and we played our square wave, you can see that it has it's let's see a more, you can see the places where it goes there. It's not like straight up and down, because it at certain frequencies, higher frequencies, it can't cope with a sudden transition, and it gets rid of the higher harmonics, and you can clearly see the difference between this. Okay, now for our chorus, we're going to use the triangle, like in like here, and because this is a stereo chorus, it does multiplies by -1 to generate two delays. One goes with the triangle wave up and down, and the other one goes with the inverted triangle wave. So here we'll need to multiply by -1. Okay, so now we have our two triangle waves. Which one will come out from there? The other one inverted will come out from there, and we'll plug it to two delays, I think. Okay, so we're adding and we're multiplying. This is the amplitude of okay, so for that, let's see, we will multiply our triangle wave. We have a multiply somewhere there, so we'll multiply both. Actually, we can avoid one multiplication by multiplying it here and then multiplying by -1. Okay, so we'll multiply it now by the depth, and the depth will be in time, how the delay changes in time. So I'm going to give it a very, very slow depth, so it's not moving much. And also the frequency of our triangle for a chorus should be quite low, like 3 Hertz. And now, because this is a delay, and the triangle goes from -1 to 1, this would cause values here to go below 0. So we'd have a negative delay, which we don't want, because that will give us some noise, some old stuff that's still in the buffer. So we'll also need to add the same value, so it goes from 0 to twice this. Okay, so let's add here. Okay, so now we can create our delays. These are interpolated delays. I'll show the labels. Oh, the labels are still wrong. So this second one is the delay amount in time, and the delay amount in time, sorry, that's where this needs to go, because this is controlling the delay, like you can see here, controlling the delay, and the in and out, in our case, are in and out there. So our in goes there, and now for out we actually need 2. So I'll create another output, because this is like a stereo chorus. So now we'll have there the 2. Now 2, because this is stereo. Now we're doing the sum of all. This sums all the voices. All the 16 voices gets summed into one mono. So let's, okay, so we can already hear something. I'm going to delete this. Okay, so one thing that I haven't showed before is a way of tidying up this schematic, which some components now have, like for example the add, it has these minimize and these. So if we minimize some of these components, we will see that it helps to tidy up a bit, and then when all the other ones will have also, it will become better. So now we control frequency, like this is 3 hertz, let's say 20 hertz. This is the depth, and like this one at 0 we would have no chorus, and this one at something like 0.0005 has some depth, but this frequency is too high, so I'll put this like at 3. And okay, so next thing we might want to do is not have to type these numbers and just use knobs. I'm going to create the knob and another knob. So this knob will control the rate. How is it called here? They don't call it anything. It goes into, yeah, they call it rate. So I'm going to call it rate 2. So this one will be the rate, and we want it to go from 0 to, like normally you would go to like 5 hertz, but I'm going to put 20 so we can try some high numbers that are not great the best, but at least you'll be able to hear. And this knob is going to be the depth, and it's going to go from 0 to 0.002. So from 0 to 0. Okay, so this is just showing 0 there, because we're only showing 2 decimal points. So I'm going to show, let's say 4, 5, and this one needs some kind of multiplying by 1,000 and maybe showing units, but for now this is what you can do. So now we need to connect our depth to there, our rate to there, and now we can try the rate and the depth. This is no chorus. That's the maximum, and 0.005. So now we have our chorus module. I'm going to give it a name, stereo chorus. But we won't have our knobs up here, and that's where you'll use these new components. I'm also going to minimize these ones because now we're using the knobs to control them. And this should show here actually the number, but somehow some bug doesn't give it enough space to show. This one -1 we don't need either. Okay, so when they're minimized, you grab them on that orange symbol. So this can't be minimized yet, the delay, the naive triangle, but they will. There's output and input as well. Like this input will become like these ones here, and the output's like the other version, the output version of these. And okay, so the way we place user interface elements on our UI, actually I'm going to put this on a separate window so we can watch the effect. Okay, back down here. So if we plug, this is our like UI content connector. When we connect it to something, we have a knob now because we connected it to this knob. If I connect it to this one, we would have that, and now we're here controlling the depth. But we want both, and this connector accepts only one view, so we can't do this. It will just show the first one. So we need H stack will show both. There's this H stack component, and the way it works is we connect it to our UI, and the second connector is the content, and the first normally connects to the next element, because sometimes you have several, this content here can have several connected in series. So now we have our user interface for our chorus, and this can be minimized. That's a bug with the labels, so I'm going to hide the labels. Okay, so this can be minimized, and like if you want them to be aligned vertically, you'd use a V stack. So you'd go there, and now there. That window shouldn't actually disappear, but anyway, we can look at it up there. And now we have them aligned vertically, and that's our chorus. Once you create a module like this one, you can select it and export and save it somewhere, and then you can bring it into some other schematic from Finder. You just drag and drop it on a schematic and you'll have it back, or you can share it with someone, send it to someone else. Okay, one more thing that this version changes is this wave selector. One more thing here is once you program this table oscillator, you don't need to have it connected, because this component keeps the table and it saves it and it loads it. So this wave selector now allows you to look at errors, like for example, this is the formula for the sine wave. If you want like 4 times the frequency, you would want to multiply by 4. So when you press multiply, you will see it has an error because this code doesn't compile. When I put 4, now it updates the view, and it the errors disappear, and it generates a table. Here it didn't update, but when you go back to it, oh yeah, because that's not what's selected there. So here we're selected now the one we're typing here. So that's quite useful. Like any error you make, it will show you. That there's a difference with this. This is showing line 1, and the error says it's 14. So line 1 is equivalent to line 14, because this code is actually wrapped inside a bigger code, just to simplify it. Maybe this will be changed in the future. And I think that's it. So you have this now here, when you have like several modules, you could plug them to your synth user interface, which will appear here, and the same thing applies here. You would connect it to your UI, and now you have what basically is your synth, where at the moment you can only control your chorus, but you would be able to control, so switch it off, But if you had like other filters and your envelope, etc., you could put them in your UI. And the way you do that is again with these three components. Actually, I didn't show. There's another one which is the Z stack. So there's H stack, V stack, and Z stack. Oh, there's scope wave here as well. You could, yeah, that's maybe something we can do here. So let's say in our stereo chorus, we would want to align them horizontal. So instead of this V stack, I'm going to go back to the H stack. And now here we want vertically, let's say with this one, we want to vertical to have first our chorus and then this wave. And now and this would be our synth. We could look at the wave, let's say after the chorus for the left channel. See how it looks. And we could also look at the scope FFT. Scope wave, scope FFT, and also if we plug it here, it should go vertically just underneath our wave. And instead of looking at after the chorus, I'm going to look at the oscillator and go also here to the FFT and plug the gate. And now we have both the wave okay, let's go again. And so the Z stack, which I will show maybe in another video, the Z stack will make them go on top of each other. So you could, from here in the contents, you could plug several things, and each one would be above the other, the one before. And this will be useful when we, for example, when we want to create a panel, like here, we might want to have a panel around it, which should say chorus, and would have maybe a rounded border rectangle. And so here we'll plug to some rounded rectangle and then plug again to our chorus. And so that's how this will evolve